We are working with Unit 5, Lesson 2. And so this is at the end of Part A of those notes. And we have been looking at exponential functions and how the function and the graph correlate to one another. So I want to draw your attention to the right side of the page over here where it says f of x equals a times b to the power of x minus c plus d. This is the general form of an exponential function, and a, b, c, and d are going to affect what the graph looks like. What we learned previously is that the a value, if it is positive, then the graph will be above the horizontal asymptote, and if it's negative, it will be below the horizontal asymptote. And we learned that D represents the horizontal asymptote itself. So if D is positive, the horizontal asymptote is above the x-axis. And if D is negative, it's below. On this page, we're going to use the exponential functions that we started with from the beginning, and we're going to complete this table. At the beginning of Part B notes, we're going to make inferences about how to determine from the equation if a function is a growth or a decay simply by looking at the graph. So I'm going to need to kind of flip back and forth from the pictures, from the graphs of the functions to this particular table. So for number 1, I'll be flipping back and looking at this particular graph, okay? So you can look back there. It says, does the graph of the function increase or decrease from left to right? So you can clearly see that it is increasing, which means that it's going to be a growth. Anytime we have a graph that's increasing, we'll have a growth. Anytime a graph is decreasing from left to right, like number 2, we will have a decay. So let's go through and take a look at all of these. So you will notice that, as we said, number 1 increases. So I'll put increase here, meaning it's a growth. Take a look at graph number 2. It's clearly decreasing, meaning it is a decay. And we'll continue on. Number 3, from left to right, the graph will decrease, meaning it is a decay. Number 4, from left to right, will increase, growth. And we'll continue on in this fashion. Number 5 is a decreasing graph, which makes it a decay. Number 6 will increase, making it a growth. We're halfway there. 7 has a decrease. 8 is increasing from left to right, even though the graph is all below the horizontal asymptote. It's still a growth. It just has a limit. Number 9 increases without bound. It's above the horizontal asymptote. Number 10 is definitely decreasing. It is a decay. A little bit. 11 increase. which makes it a growth. And finally, number 12 will decrease, making it a decay. All right, so that's pretty simple to simply observe. Now we're going to see, based on the equation, has there been either an x or a y-axis reflection? So we're looking for negative signs. Particularly, we're looking for negative signs either in the front of the function, making the a value negative. That would indicate a reflection over the x-axis. In other words, the graph would flip upside down. Or we're looking for a negative sign just with the x. That's an internal negative, and that would make the graph have a reflection over the y-axis, so it would flip left to right. So it would flip horizontally. So number 1, we don't see anything. Number 2, number 3, there is some negatives, but not in the places I'm looking. Number 4, number 5, number 6. Number 7 is the first time I see a negative sign either in front or with the x. So for the first 6, I'm just going to say none. All right. Now, number 7 has a negative sign with the x. Remember, that means a y-axis reflection. Let's see if we have any others like that. Number 9 has a y-axis reflection. Number 11 has a y-axis reflection. So 7, 9, and 11 have a y-axis reflection. 7, 9, and 11. Okay. Number 8 has a negative sign in front of the function. Number 10 and number 12. These all indicate a x-axis reflection, a reflection vertical, flipping upside down. So we'll fill that in. And finally, it says, is b greater than 1, or is 0 less than b less than 1 in the equation? So the b, remember, that is the base of our exponent. So is it greater than 1, or is it between 0 and 1? That's the question. So let's do some observation here. So in number 1, the b value is 2, which is clearly greater than 1. For number 2, the b value is 1/2. That's between 0 and 1. And for number 3, the b value is 2/3, which is between 0 and 1. Okay, so let's go ahead and add that to our chart. So number 1, the b value was 2, greater than 1. For number 2, it was 1/2, which means it was between 0 and 1. And for number 3, it was 2/3. So the b value is between 0 and 1. Let's take a look at the next ones. Number 4 has a b value of 3 divided by 2. As a decimal, that's 1.5, so that's greater than 1. Number 5 is 0.4, that's between 0 and 1. And number 6, the b value is 3, which is greater than 1. So let's add that. So number 4, the b value was greater than 1, 3/2. Number 5, it was 0.4, so that's between 0 and 1. And number 6, it was 3, so greater than 1. All right, looking at number 7, we have a b value that's greater than 1, which is 2. Number 8, the b value is 1/2. That's between 0 and 1. And number 9, we have 2/3, which is, of course, between 0 and 1. Let's add this to our chart here. So 7, the b value was 2, which is greater than 1. For 8, the b value was 1/2. And for 9, the b value was 2/3. Both of those are between 0 and 1. All right, finally, we have a b value of 3/2 again. That's 1.5, so that's greater than 1. 0.4, which is between 0 and 1. And 3, which is greater than 1. So 3/2 is greater than 1. 0.4 is between 0 and 1. And 3 is greater than 1. All right, we want to make some observations here. So here we had a growth where the b value is greater than 1. We have another growth where the b value is greater than 1. Growth, b value greater than 1. This growth has a b value between 0 and 1, but remember there was a reflection. Here's another growth with a reflection with a b value between 0 and 1. Another growth with a reflection with a b value between 0 and 1. What we can observe here is that an exponential growth occurs when your b value is greater than 1. Unless your b value is between 0 and 1 and you have a reflection, then you will also have a growth. Otherwise, a decay can be found when your b value is a fraction between 0 and 1. Here's another decay where the b value is between 0 and 1. And another. It's when we start having reflections that changes. Here's a decay where the b value is greater than 1, but that's only because there is a reflection. And any type of reflection will change a growth to a decay and vice versa. So on this next page, we can kind of summarize what we have learned here. So this is the start of Unit 5, Lesson 2, Part B notes. And it says, after completing the table on the previous page, you should now be able to make 4 preliminary inferences as to how to determine, based solely on the equation, if an exponential function will have a graph that represents a growth or a decay. So here's what we notice. If, it's supposed to be an F, if your b value is greater than 1 with no reflections, your exponential function will be a growth. Okay, so that's kind of the standard. You're multiplying by something greater than 1, which means it's going to get bigger. Okay? But if your b value is greater than 1, and you have one reflection, and it doesn't matter if it is y-axis reflection or x-axis reflection, it's going to change from a growth to a decay. All right. And then, of course, what else we observed is if your B value is between 0 and 1, which we write like this, with no reflections, excuse me, your exponential function will be a decay. But of course, if the B value is between 0 and 1 and you throw in a reflection, that will change it to a growth. All right. Now, there is one scenario that we have not included in our inferences. We have not included the possibility that you might actually have two reflections. You might have a negative sign in front of your function for your A value. You might also have a negative sign with X, and this would cause you to have a reflection across both the X and Y axis. And so we need to kind of finish this off with that discussion. So, what is the only scenario not included? The case with two reflections. So, let's explore that to finish up this conversation. All right, so here we have something that where the B value is 2/3. So the B value is between 0 and 1. Okay, that would generally indicate that we have a decay because we're multiplying by a fraction less than 1. That's going to cause the number to get smaller. But we have two reflections. This indicates a reflection over the x-axis. This indicates a reflection over the y-axis. So we have two reflections. So let's just think about what happens when you sketch this. Okay, if you have again, the 2/3 would indicate that we have a decay, something going down. If we reflect it over the x-axis, it's going to flip upside down. And then if we further take that and flip it across the y-axis, now it's going to look like this. Okay. And so the decay with one reflection becomes a growth. With another reflection, it becomes another decay. And that makes perfect sense. If you flip it once and it changes, you flip it again, it's going to change back to, and it's still not going to look like the original because it's being flipped across a different axis, but it will be a decay. Let's look at this one where the B value is 2. So the B value is greater than 1. We have a negative sign, so the A value is a -1. We also have a negative sign in front of X, so we have two reflections. So we're going to have this same scenario, except that we're going to start with B greater than 1. That indicates that we have a growth. But again, if you flip it across the x-axis, it flips upside down. And then if you further flip this across the y-axis, then it's going to turn into a growth. So a B value greater than 1 indicates a growth. 1 reflection changes it to a decay. 2 reflections turns it back into a growth. And finally, we have another one where the B value is between 0 and 1, 1/2. We have 2 reflections. We have a y-axis reflection, an x-axis reflection and a y-axis reflection. So the 1/2 indicates that we have an exponential decay. When you multiply by a half, it gets smaller. It cuts it in half. Reflecting across the x-axis would flip this upside down. And reflecting across the y-axis would flip it vertically, and so would end up a decay. So again, the B value being between 0 and 1 indicates a decay. 1 reflection turns it into a growth, but 2 reflections back into a decay. So in the next video, we will clean up the inferences that we made earlier in the page to wrap this up.